Today we will create an Excel calculator for performing a one proportion confidence interval so that when we have to do repetitive calculations, i.e. we have these types of questions over and over and over again, we don't have to reinvent the wheel. We can just change the conditions of that question and Excel will spit out the new confidence interval for us based on those conditions. Remember, we will only change the values in the yellow squares. So the first thing we have to change is our confidence level, which is 0.96. Then our sample size was 300, and the number of successes we had was 146. Now, how did all this change? Well, it's pretty easy. This first cell is literally just K over N, number of successes over our sample size. So in this cell, it just says equals A5 divided by A4. It's always going to take my number of successes divided by my sample size, and that's going to give me P. And then Q is always just 1 minus P, so that's literally just 1 minus whatever number is sitting in this cell, and that gives us that. Alpha, remember alpha is our error rate, which is always 1 minus our confidence level. So this one, just like the cell above it, is simply going to be 1 minus a different cell. But in this case, it's 1 minus this one, right? Because we've taken the opposite of our confidence level. Now, our Z critical level, the thing that we have to use to plug into this formula, right down here, the margin of error is going to be some sort of Z critical value times, basically this is kind of like a standard deviation of our distribution. Well, the Z critical value always changes depending on what our alpha is, right? They always call it Z of alpha over 2. Because you'll recall we've got the nice little normal curve. We have the confidence interval sitting in the middle of it, and then in each tail is half of our error rate, half of our alpha. So if our alpha is 4%, we're going to have 2% in each tail. Now, in order to get a Z of 2%, right, i.e. what's the Z critical value that has only 2% in the tail above it, in Excel and also in a lot of technology, to find that value, you have to tell the piece of technology the proportion of area that's below it, to the left of it. So if we have 2% in the tail above it, we have 1 minus that, or 98% below it. And that's where this calculation comes from, is finding that area below it, which, as I've written here, is simply just our confidence level, 96, plus our alpha divided by 2, so plus half of this. So in my calculations, I just took this square and I added this square divided by 2, right? So I have A3 plus A8 divided by 2, and that's going to give me that 98% that I can then use to solve backwards for my z-score, and that uses the norm dot inverse function. So the equals norm dot inverse function asks for 3 things. It says, give me the percentage of the distribution that is left of this critical value that you're trying to find, comma, give me the mean, comma, give me the standard deviation. So in the case of this, I told it take A9, because that's going to be the area that's to the left of my value, and then I put comma 0, comma 1, because we're doing z's, so we're living on the standard normal z, and the mean of the standard normal is always 0, right? The standard deviation is always 1. So that's how I end up getting my z-score. Now, all I have to do is calculate my standard of error, my margin of error, or what's sometimes called standard error, and that's using this formula. So we're basically just going to write this formula in Excel, but use references to other cell values rather than typing in, what the Z alpha is, what the P hat is, Q hat, and so on and so forth. So it just equals my Z of alpha over 2, which is the value in A10, and then times, so I've got to put the asterisk in there. Then I'm taking the square root, so that's SQRT, right? That's the shorthand to tell Excel to take a square root of something, and then you put inside the parentheses all the stuff that you're taking the square root of. So I need P hat times Q hat. Well, P hat is just the value that's in A6, and then asterisk, the value that's in A7, and then / for division, the sample size, A4. Close the parentheses, hit enter, and there is my margin of error. Almost 6%. So it's going to go plus or minus 6%. Now, to find the lower confidence interval and the upper confidence interval, basically the lower value, the lower bound and the upper bound of our confidence interval, we simply just take our p hat and plus and minus our margin of error. So this cell is going to be this one minus this one, and then this cell is going to be this one plus this one. So you can see that there is A6 minus A11, and then the next one is A6 plus A11, and that is going to be our margin of error. Now we have a nice Excel calculator to do these computations for us. Because now we can come along and the next question could be, okay, give us a 95% confidence interval, and here they could change it up. Instead of telling you what your sample size was, or they would tell you what the sample size, they say, okay, you went out and you took a sample size of, let's say, 500. And in that sample, 33% of your sample thought whatever, right? So that was your success rate. Well, how do you figure out the number of successes? Well, that's really easy. Your number of successes, remember, is n times p. So you just do equals, 500 times that 0.33%, and then make it big enough so you can see what it is. So that tells me 165. So then I would come here and I would do, oh, all right, so that means I had 165 successes. You'll see that my P is 33 like it said it was, and then everything changed, right? Here is my new Z to only be 95% confident. It's basically 1.96. Here's my new margin of error of only 4%, and here's my new confidence interval of basically 28.9 to 37.1. So that's the nice part about using Excel, is we can do multiple questions much quicker, because all we have to do is change the stuff in yellow and then everything else changes for us. Okay, hope that helps.